Okay, welcome to video 4.2. We're going to talk about more slope or average rate of change. So just remember that the formula to find the slope is m equals y2 minus y1 over x2 minus x1, or the change in y over the change in x. So to find the average rate of change over this interval, -3, 0, that's telling you that these are my x values. So I need to look for the points when x is -3 and when x is 0. So first I need to locate those places on the graph. So if I look over here, back 3, on this function, that point is -3, 4. So if it helps you, you can write it out first as a point. And the other piece is when the x value is 0, and if I look at my graph again, so that means I'm not moving left to right at all, so I'd have to go down. This is that point, 0, -4. So then once I write out my points, if it helps you can write the x1, y1 underneath and the x2, y2. And just remember that those are so that we remember that whichever one we start with for the y's, we have to start with again for the x's. So m equals y2, I'm going to use -4 minus y1, which would be 4, divided by x2, which is 0, and y2, which is, or x1, which is -3. So then I get -4 minus 4, that's -8, and 0 minus -3 is 3. So my slope is -8 divided by 3, and I can put that in my calculator and see what I get, and then math frac it back, and it'll give me the same thing again. So my slope here is -8 over 3. So we'll finish this question off. Next part says find the average rate of change over this interval -2, 0. So I need to look back at the graph, but this time there isn't a point labeled for me. So if I go to an x value of -2 and I go to the function, I can see that that y value is also -2. So it really helps to write out that point as -2, -2. And then they told me that I was going to 0, which is going to be the same point as before. So m equals, and then I'll do my y2. Again, you can label them if it helps you. So I'm going to use the second point that I wrote, so -4 minus -2, because that's y1, and that's divided by, since I started with -4, I have to start with 0 minus -2, which when I put those in my calculator, remember we simplify the numerator, simplify the denominator, and I get -2 divided by 2, which is -1. So -1 is my slope for this interval. Okay, so in this next question, it says that the graph models Craig's trip to visit his friend in another state. In the course of his travels, he encountered both highway and city driving. So we need to, based on the graph, figure out which interval did Craig most likely drive in the city and explain your reasoning. So for this one, I have to look over at my graph and figure, well, we have to know something about city driving. If we're going to be driving in the city, I'm going to say that our hours spent, so as time goes by, we're not going to be traveling very fast. So we're probably not going to travel, I don't know, for example, from 0, 0. In 2 hours, they drove all the way 110 miles. Well, that's probably driving, if we figured it out exactly, we could divide 110 divided by the 2 hours and figure out what the speed is here, which is about 55 miles per hour. Well, I'm going to say that's probably not city driving. Then if we look from B to C, well, that means that my time is going by. It's been 2 hours and then 4 hours, but my distance has not changed at all. So I don't think that Craig is driving during this time. And then from C to D, we're going again in the span of, well, it's from 3.5 hours to about, we travel this down 5 hours, so that's about an hour and a half. And he has driven from 110 to 200. So that's again pretty fast. But then if I look at this last part, D to E, I can see that in a time from 5 to 7 hours, so 2 hours, he's only driven from 200 to 230 miles. So he's only driven about 30 miles. So I'm going to say that this is probably a city driving, which is a lot of traffic, not a highway, not going very fast over a period of time. So that's probably where he was driving in the city. So that's what we would write for this one. So I just said DE because in the city the speed in miles per hour is likely lower, so less miles are covered in 1 hour. This means the distance covered would be lower. And remember that we're talking about how much miles, that's a rise, covered in an hour per hour. So that's slope. So this is talking about the slope of the line. Okay, so I'll leave the rest for you to do, and we will see you tomorrow. Have a good night.